We ask a lot of chemistry students when we expect them to watch a chemical reaction in a test tube and ask them to summarize what is happening using abstract chemical symbolism. Chemical education research shows many misconceptions arise from misinterpreting what these symbols mean. Expert chemists can watch the same reaction and in their mind zoom down to the invisible molecular level and imagine the hydrated sodium ions and chloride ions in the sodium chloride solution and the hydrated silver ions and nitrate ions in the silver nitrate solution. When the solutions mix, they can imagine the hydrated ions colliding with one another. When silver and chloride ions collide, they can imagine the formation of transient ion pairs that combine together to form an extended ionic lattice of silver chloride, with ions leaving and joining the lattice. The sodium and nitrate ions don't take part in the precipitation reaction. So it's easy to see that the nitrate ions are not involved in the precipitation and are called spectator ions. For experts, the symbolism and terminology are meaningful because they can relate these to molecular level images in their mind. In an immersive institute, you will learn to use dynamic animations and simulations like these to help students to imagine what is going on in the common types of reactions they encounter in high school chemistry. As you'll see, it is not a simple case of just showing them the animations. They are complex, and it is easy to miss the key features we want them to see so they can transfer their imagery to new substances and reactions. Students need to engage with these animations in a deep way and to construct their own mental models, often by modifying their existing model when they realize its explanatory limitations. To achieve these aims, we will use what we know about how the brain processes audiovisual information and use a cognitive learning model to help students to express and refine their imagination of the molecular world. This is the key to help students to go beyond just description of chemical reactions and substances, to explaining what happens and understanding chemistry more deeply. This is consistent with the new next generation science standards.